Alright, steel rose metal coat. Thought I'd go over a quick little putting a corner on a Volkswagen van, basic sheet metal replacement. First I put it up there, get it in line as much as I humanly possibly can with the flanges on there, and then I mark out roughly where it's going to set, which the mark was already there. And then normally I'll go about 3/4 inch lower than the line. It doesn't have to be exact, just around 3/4 of an inch lower so that I can work my way up to it. Normally I'll take a cutoff wheel. This actually is a pneumatic Sawzall. It's a Matco Sawzall actually. Mind you, I don't have any sponsors, so that's just what I choose to use. I like it. And then I'll go tracing a real rough cut around that 3/4 of an inch lower than what my actual line needs to be. Being as precise as I can, but not wasting a bunch of time. Just getting things rough cut out of the way. Then I'll zip it back on around. Normally what I do is I just rough cut the bulk of it out of the way, making sure that I don't go too far. There's an inner panel in here that you'll see in just a minute, but I'm cutting up to the flange and then making sure that I'm not cutting the flanges. The same thing on the back side. There's like a bar there that you'll see in just a minute, but I don't want to cut that. So I'm being mindful of everything on the inside of that piece. So get that cut around, and then normally I'll cut the flange off with a 4-inch angle grinder. I'll cut this front flange off. That's the flange in the motor compartment. Like I say, just barely going through the sheet metal, being super careful that I don't cut anything back behind it. And then I'll run that around. And then the same thing on this leading flange underneath that little light piece. That's actually a seam right there. So I'll jump over there, being super careful that I'm not cutting anything on the backside that I'm not supposed to. Normally, like on that one, I'll space it about a 1/2 inch off of the flange. The other one, I cut it right on the corner because there's a dead set corner. That one, I'm cutting about a 1/2 inch away just so I can get the bulk of the piece out of the way and see what I'm contending with on the inside. Then, once I get those pieces out of the way, of course, there's that inner piece that is spot welded all the way around this piece, as you'll see in just a second. Looking in there, making sure everything is cut completely. There's a small little piece on the bottom that I missed. Going back, trim that off, making sure that's cut. The biggest deal is making sure you don't cut anything you're not supposed to. So all of that looks pretty good. It's relatively loose other than that panel on the inside. So we go to the inside. All right, and of course you can see the rot holes in it. So I'll just pick one of the rot holes and get the bulk of the thing cut out of the way. All the way up to, you can see that flange on the inside that I was talking about, where the two pieces of metal come together. So I'll get that cut to there, and then I'll flip my pneumatic Sawzall and do the exact same thing, pulling it back to me to the other cut, just to get the bulk of that out of the way. Definitely not glorious work. It's rust repair is always dirty, grimy work. Get that piece cut out. As you can see, it's barely hanging. You can see the rest of that tray that's in there. Get a few little pieces nipped out of the way. There we go. Now we can see what we're working with. That's the bar to your right that I was speaking about, making sure that I didn't cut. There's a dent right there, so it's not in the video, but I got to play with that dent for a little bit. This right here is something I wanted to highlight, and you can get these from just about any tool supplier you want, so I'm not even going to name names, but what this thing is a seam splitter. Now, it's basically a hardened piece of steel that's like a chiseled knife, right? You hammer on this thing and get it in between your two pieces of metal, and it'll cut your spot welds. It'll save you a lot of time and money not dealing with spot weld cutters. I commonly will take this, run it through there, and then run a grinder and basically knock off the top of the metal and clean it all up. And then once I get the metal popped out of the way, I'll grind down. You'll see little dimples where all the spot welds are. But yeah, so meticulously I take this thing, go through all of the flanges that are left there, including that inner tray piece. There's 3 flanges or so on that tray piece, so I'll get the bulk of the metal cut out of the way and then come back with a seam splitter and get it all cleaned up. Also, you can sharpen those things, so you just throw it over on a grinder and sharpen your edge up. Of course, you don't want it to be like a razor knife. You want it to be a little bit blunter, or you'll just beat the tip off of it. But yeah, definitely go get you a seam splitter. It is the best tool in the shop. So get it refit back up there. Like I said, 3/4 of an inch. Now, you didn't see me start this, but what I did is I overlaid these two together, and then I clamped it into place. Normally what I try and do is just barely cut the new metal, the top of the new metal, make sure that my saw is super straight, and then cut the metal behind it. And what that does is it ensures that the 2 pieces of metal match up identically, no matter if there's a waver in your cut or any of that. The main thing you have to make sure of, mind the terrible camera angles, is to cut them together, not get off of one piece of metal or the other, or it'll create a hellacious gap. So you don't want that. So I just walk around the piece, overlaid, those 2 pieces are lapping each other, and then cut both pieces at the same time. Again, here being careful not to cut that bar. And once I get that wrapped around and all trimmed up, and the flanges trimmed up, because you'll have to do some of that. On the other side, I kind of V-cut it down so I can miss that little small marker light over there to the other side. Then, of course, there's always going to be little extra things that you gotta get out of the way. Seam splitter's perfect for weird little angles like that, corners that you have metal. It'll also cut the metal. So, especially if it's thin metal, you can just run that thing through it. So, definitely get you one of those. It'll save you a lot of hassle. So get all these pieces cleaned up, little bear claws out of the way, and get the thing back lined up. Get it back in there. Of course, I started by clamping everything into place, and what I'm doing is I put the inner lip in the motor compartment. I got that clamped into place, and then I basically started working my way around to the front side of the vehicle. And what I'm doing is those aftermarket pieces never fit properly, right? So I'm working the excess of the metal toward the driver's front. The back lined up just fine. And the purpose in that is you can see on the left hand side of your screen there's a little bit of a gap where those 2 pieces of metal come together. So I'm just working that excess on around toward that gap so I can close it up validly. Also, I'd like to point out this right here. So I cut it all together and it matched up great, and it actually had the gap of the Sawzall blade in it, right? But as you start welding it, that seam starts shrinking up, and a lot of times it'll in sections start overlapping itself again, which is no big deal. Just go back through and clean that edge again with your pneumatic Sawzall, and then go back to getting the thing tacked into place. You'll also see that sometimes the clamps are great, but other times, like in spots like this, the clamp, even though it's a 24-inch clamp, it ain't working so well. I'd also like to note the top part of that clamp, how it's got a long round piece on that. Gene Winfield actually showed me that, taking a regular clamp and then just some, I think it was 3/8 or 1/2 inch round stock, and TIG welding it to that. Those 24-inch clamps wants to roll over on you when you put any kind of real pressure. This stops that from happening. If you put that small, it's probably a 2-inch piece of round stock that I just TIG welded to the end, but that was a super handy trick that Gene showed me. Again, the gaps aren't lining up super proper. And like I say, a lot of times what I'll do is to keep that gap down is I'll cut it on a bevel or an angle. And what it does is it makes those pieces of metal lap over a little bit easier, to where you get a tighter fit than if you were to just do it straight, because you'll get a 1/16 of an inch gap, depending on your blade size or if you're using an angle grinder. So I reopen that up a little bit, decide that these clamps are really not doing what I want them to do, right? So what I'm going to do is get her on around here, and I'll start using another thing that is super handy if you don't know about them. And what they are is they're butt weld clamps, right? That's what I'm putting on there. And it's you can find them just about anywhere. I mean, if you want to go online and get them or whatever. But it's a piece of square with a notch cut in it, and then it has a wing nut on it, and then it goes through another flat piece that holds a piece of square stock on the back. If you want to look at those closer, they're called butt weld clamps. So I start working those around to work that excess metal. They'll get it pretty close to flat on compound curves. They're better on dead flat surfaces, but a lot of times I'll get these and they'll be like a 1/16 or something like that. Still that it needs to shrink up, and you can kind of push down on them one way or the other and close that up sometimes. Other times I'll take a hammer and I'll just work on it with a hammer in between to get it fine tuned in. The flusher you have your metal, the better the weld will grind off, and the more it'll look like one piece. That's really the most critical part. You see it a lot where people weld sheet metal together, and I mean the weld is just blatant in your face, because it's a struggle to get it to lap up properly and on the same plane, and you don't have a whole lot of tolerance to grind that weld down, because you're dealing with most of the time 18 gauge, sometimes on modern vehicles 22 gauge, and it's a sheet of paper thickness. So on modern vehicles, older vehicles are better. So we get this thing butt welded or butt weld clamped into place, and notice I leave enough gap in between the two to fit the tip of my MIG welder, so that I can get it tacked as it gets flushed around. And a lot of times you need to be mindful of, again, when you weld it, that gap shrinks up. So when you're going to take these butt weld clamps back out, sometimes it's a pain. You just got to be careful with it, work it back and forth, and make sure that you don't warp up the metal as you're taking that clamp out. So got it in there, got it pretty decently flush, and then I'm just going to go right beside them where it's at its flushest point and throw some tacks in there. And then again, far enough apart for the head of my welder, throw a tack in there. That one I wasn't really liking how well that seamed up, so I decided not to tack that one. Definitely take your time and make sure that your metal is as flush as possible. It'll save you a bunch of hassle on the end when you're working everything. So as you can see, that gap closed up, right? So I pulled the piece of square stock out and the butt weld won't come out, right? So get the piece of square stock out of there, and then I just start shifting it back and forth and it'll come on out. Same thing on the other one. Might have put a little bit too much of a gorilla hand on that one, but get it tightened down, get the pieces together, and get them as smooth as possible. Another thing is being mindful of where you're at, around that curve, that needs to be on a contour. Pay attention to the metal that you're putting together. If something doesn't look right, figure out how to get it to where it's nice and straight. So I move one of the clamps on down, trying to get the two pieces of metal, because of course that aftermarket metal, it's got it's got a contour right there, even though the side of the factory panel is relatively flat where that light goes. Again, the aftermarket panels, they just aren't made very great at all. So I'm going on the back side and I'm just tapping at the top side of the metal, the blue metal, to get it kind of pushed out just a little bit more to where they can seam up, like say on a level plane. Just be slow with it, especially when you're tacking pieces together, you know. Don't get in a rush. Tack them, get them tacked into place, let them cool down. The slower you do that, the better, the less warpage you have. Again, metal isn't lining up as tight as I would like it to, so, you know, just tap on it, play with it. Use a hammer and a dolly. What I'm using there is actually the sharp point of a teardrop mallet, just so I can push out on that welded seam. So getting those pieces worked on around and in place where I like them and tacked up. Now I'm using an actual body hammer and a dolly. I'm using the round hill of that particular dolly, the flat parts against my hand, because the bottom's looking a little fat. So I'm actually holding the dolly on the blue metal. It's not on the green metal, and then I'm hammering the green metal toward the blue, just to give it some rigidity and get them in line the way I want them. And then that's actually the exact opposite. I'm hammering on the dolly directly on the seam to kind of pooch that seam out a little bit. It'll save you a lot of time in the grinding, cleaning process if you do that. So yeah, pretty simple stuff, right? Got it all nice and lined up. Don't like the way that those butt weld clamps are holding everything over there. So start taking those out so I can play with it a little bit longer. Those clamps just weren't holding it the way that I wanted it to, so get those on out of the way. Also, pro tip, you see me taking extra time to put the square stock back in the butt weld clamp and tighten it up. That'll save you, you know, hours of having to look for that square stock. Of course, I normally keep some of that square stock in-house just so I can cut new ones when I lose them, because they'll fall in between panels and everything. So get those out of the way and then start hammering on this thing a little bit more. Try and get the, again, the dolly is only on the blue metal. Try and get that rolled a little bit flatter than what it is. Start getting that into shape so that I can get it tacked around. You'll notice that the gap on the left hand side in between those two panels has shrank up from when we first started working on it. It's probably, I would say it's probably less than an 1/8 inch. Maybe, you know, I would say probably 12 gauge metal could fit in between there. So it's not as tight as I want it, but it's rolling on around there. Again, not hammering on the dolly. The dolly's just holding the blue metal. It's higher than the piece of green metal. That's important. A lot of people just want to beat the hell out of the metal on top of the dolly, which I'll explain in just a minute how that's not a great thing to do. I mean, sometimes it's necessary, but not all the time. Finally get it where I want it. Throw a couple of little tacks in there to hold it nice and flat. And then I'm all the way to that clamp, right? But it's actually, it's bowed out quite a bit right there. So I'm gonna have to do a little bit more work to that. All right, so what we're doing is we're tacking this in place. Now, just a second ago, you might have wondered why I used the butt weld clamps through here and then I pulled them off there. But if you look closely, you can see where this is lipped out, right? This is pretty well flat, which is what it's supposed to be. The aftermarket piece had too much of a bubble in it. So what I'm going to do is use the technique you just seen a second ago, which is hammer off dolly. So a lot of people think that you hammer on the dolly, and sometimes you do. It depends on what you're trying to do, but there's two different techniques. It's hammer on dolly and hammer off dolly. Hammer off dolly, in this specific instance, what I'm doing is I'm putting the dolly against the actual metal, the blue metal that is the Volkswagen, and I'm hammering on the green metal, which is the aftermarket piece. I'm trying to keep the blue metal as flat as possible while causing the green metal to shrink in. So every scenario isn't good for hammering on a dolly. Actually, if you dig deep into that, there's some guys out there like Ron Cavell and a few other of the more technically explaining guys out there that'll kind of give you an idea of what that is. You're basically stretching the metal when it's hammer on dolly. So if you have a high spot, right? A lot of times high spots and low spots, they're created from dents, so that causes that metal to stretch. Okay, so when you're hammering that metal, you don't want to just hammer it straight on the dolly. What you're doing is you're causing it to stretch more, and then you'll get an oil can effect. That's not what you want. So a lot of times you can do a donut dolly, which is something that my friend Robert McCartney turned me on to, which I think is excellent. And it's basically a dolly that is the shape of a donut. It can be made out of various different things. Use your own imagination. And it goes around the outside of the dent, right? And when you hammer on the dent into that donut shape, what it's doing is it's capturing that dent all right in there. And you're actually folding the metal microscopically over itself, which is how shrinking is done. We'll do a video on shrinking and stretching and ways you can do that a little bit later on. So anyways, I'm going to do some more hammer on dolly. Once I get this piece welded or tacked into place, I'll go through and I'll finish weld everything. But you guys don't need to sit here for 10 years watching that. All right, there we go. Got a corner put in. We still got to do the inner tray pieces on both corners. That was probably right at 6 hours to get all the inner tray cut out, all the pieces that are flanged over and spot welded, all those cleaned out, everything cleaned up to where I could fit the piece and then cut, weld, and clean up said piece. About 6 hours total. And then of course, like I say, we still got to do these inner tray pieces. Those pieces right there that of course were rotten. We got new ones. So we're going to, all that stuff's been pre-cleaned up. So we're going to get those fit and welded in and keep jumping away on this thing.